In this problem, we're given two equations, f of x and g of x, and we're asked to add, subtract, multiply, and divide each, and I'm given no x values to substitute. So when I do these problems, I'm going to think of it as I'm making a series of substitutions. Wherever I see the notation f of x, for example, I'll be replacing the notation f of x with x squared minus 13x. In mathematics, if two things are equal, one thing can be substituted for the other. So in the first problem, where it says to take f of x and add g of x, I'm going to make a substitution for both functions. I recommend that whenever you make a substitution in math, you use parentheses around whatever you're substituting for. Half the time it won't be necessary, but the other half it would be. So where I see f of x, since they define it to be x squared minus 13x, I'm going to replace the notation f of x with x squared minus 13x. And if you don't know whether you need the parentheses or not, you should always put them in. G of x is given to be x plus 11, so I will replace g of x with x plus 11. And as usual, I'll put parentheses around my substitution. Notice we're supposed to add the functions. In both these substitutions, it turns out I don't need the parentheses. Since there's nothing outside the parentheses here, you could think of it as a positive 1. And when you distribute a positive 1, nothing inside the parentheses changes. So it turns out when I made my substitution, had I thought of this, I would not have needed the parentheses. Or you can think of it as you always put the parentheses and then simplify like I'm doing here. So in this problem, there's nothing left to do except for combine a couple like terms, and I'll be done. Negative 13x plus x is negative 12x. Here I have a plus 11. That would be my final answer for the first one. You could write this as f of x plus g of x is equal to all of this. If this was a workout problem on a test, this is how I'd write it. But in Math.is, since they wrote this side of the equation for you, you would just type in x squared minus 12x plus 11. I'm going to have to clear this out so that I have room for the next problem. The next problem is exactly the same thing, except this time I'm supposed to subtract g of x. So in this problem, I'm going to write f of x, subtract g of x, follow the same procedure I did before, making substitutions with parentheses. I'm going to substitute whatever f is in here, whatever g of x is in here with parentheses, and subtract them. F of x was given to be x squared minus 13x. G of x was given to be x plus 11. In the first case, you notice there's a positive 1 out here. Upon distributing, it would not change anything in the parentheses. But in the second part, however, since there's a subtract symbol here, you could think of it there's a negative 1 there, and you're multiplying a negative 1 through using the distributive property, which changes the signs on both terms. This is an example where if you did not use parentheses in your substitution, you wouldn't get the right answer. Here I'm going to have a minus 1 times x is negative x, a minus 1 times 11 is negative 11. And again, your teacher might not give you full credit unless you simplify your answer. So negative 1 times 11 was negative 11, and I'm going to combine the middle terms here because they're like terms. A negative 13x and a minus x is minus 14x. And then I have my minus 11. Again, in Math.as, you would type this answer in like this. If this was a homework problem or a workout test, your teacher would want you to write your final answer like this, stating the original question, f of x minus g of x, so that we know exactly what we've written here. F of x minus g of x is equal to x squared minus 14x minus 11. I'm going to keep going through doing the next two problems exactly the same. Although they'll look a little different each time, it's the same procedure. I'm making a series of substitutions. Here you have f of x times g of x. Following the same format, I'm going to take f of x and replace it with whatever it is. I'm going to take g of x, replace it with whatever they define that to be. And then since there's no symbol in here, the implication is that there's multiplication. F of x was given to be x squared minus 13x. G of x was given to be x plus 11. In this case, you have two binomials being multiplied. We call this the product of two binomials, in which case to simplify it, you would need to use the FOIL process. I never think of it as FOIL myself. I think of distributing it twice, two different things. I distribute the x squared to both of these terms, And then I use the distributive property to distribute the negative 13x to both terms. But you probably learned this as a FOIL process. In any case, the x squared gets multiplied by the x, giving you x cubed. The x squared gets multiplied by the 11, giving you 11x squared. Negative 13x times x is minus 13x squared. Negative 13x times 11, I guess let's play stump the professor here. 13 times 11 is 143, but a negative times a positive is a negative. So that's negative 143x. And I'm still not done unless I simplify these two like terms in the middle. Again, by now you know I'm going to say that your final answer should state what you're actually finding. What we found is that f of x times g of x is equal to x cubed. You have 11x squared minus 13x squared. That simplifies down to be minus 2x squared. And then finally you have a minus 143x. And that would be my final answer for that part. And the last example, I guess I have room over here. You have f of x divided by g of x. So I'm just going to make my substitutions. F of x was given to be x squared minus 13x. Again, if you're worried, make sure you put parentheses. Divided by g of x, so I'm going to put g of x in parentheses. G of x was given to be x plus 11. Because there's no number out here besides a positive 1, again, distributing a positive 1 does not change the results inside. So what I get is a result that basically says that the parentheses weren't necessary at all. This is my answer, but most faculty will want you to simplify your answer by factoring the numerator. Because my numerator has a greatest common factor of x, you could factor it out. If I factor an x out, I have to ask myself, what do I multiply x by to get x squared? Well, that would be x. So far I have x times x is x squared. I need to put something here so that when I multiply by x, I get negative 13x. Well, that would be minus 13. You can check your factoring by distributing the x. X times x is x squared. X times negative 13 is minus 13x. I'm done factoring there. My denominator is x plus 11. Because my numerator and denominator have no common factors, I can't simplify further. But had I not factored that, I might not have noticed that they have no common factors. So my final answer on this one would be that f of x divided by g of x is equal to this right here.